Hi, good morning, everyone, or good afternoon, depending on what time you watch this. Hopefully, by the time that you watch this, you will have had an excellent long Memorial Day weekend, and I hope that you all enjoyed it, got out and got some sun. Um, I'm recording this over the weekend right now because uh, apparently I don't like the sun. No, I'm going to go outside pretty soon. Um, but I know I didn't send this out last week. I didn't get a chance to record this video. I did have the activity kind of all set, but I don't like to post things for you guys without some sort of face to face, well, at least my face, and some sort of like walkthrough. So I'm going to do that now, and hopefully that last week the little math game that the unit circle game that I shared with you was a good review, so that you kind of have solidified some of that on your own now. This week, week 9, which is the second to last week that we're going to be having distance learning activities. Yes, right? Am I right? Um, so we're going to take a look at the graphs of sine and cosine functions. So these two primary trig functions, what do the graphs look like? And how do we get to those? And then we're going to look at some of the features of those graphs. So go ahead, go sign in. Every now and then, just like before, I'm going to have this pause screen up. So feel free to pause the video, think about what you're going to do, work on a little bit. I'm going to try to keep this quick because I know the videos have gotten like longer every week. And you can tell I'm actively talking faster. But I'll pause the video once in a while and have you guys do stuff and then have you unpause it and come back. And I'm not going to do every screen for you or with you, I should say. Because I want you to do some of it on your own and start to have this sink in. I know summer's almost here, but we can get there. And I want you to try to learn some of this on your own. So let's see. First screen I've got here is select the graph that best represents your energy level over the past week. Well, this depends. It's gonna be based on what you think. So pick one of these screens, and then there'll be a little thing that says, um, "Why did you pick that one? Explain why." So go ahead, do that. First pause of the video. Go ahead and try it yourself. Okay, so for me, let's see. I don't know what you picked. I'll take a look at it though. Has my energy been going up? Not really. It hasn't been constantly going down either, though. It's been kind of like one of these up and down kind of curves. I don't know. I guess has it been relatively stable, or has it kind of like swung a lot? I'm gonna say it's actually I've had a lot of swings. I've had um, a lot of kind of energy swings lately. It's like one day, I'm like super energized. I'm ready to do some work, be productive, and then the next day, I'm just like, whoa, where did all that energy go? Right? You might feel that way too. Um, I'm not sure. Okay, so what's on our next screen here? By the way, there are 30 screens, but I'm gonna, like I said, try to make this quick. So this is a 2-minute breathing exercise. I thought there are two good reasons to do this. One is because it's good to take kind of a mental break once in a while. Take 2 minutes to center yourself, and so this is a breathing exercise to focus on your breathing. And two, this actually kind of related to the topic today. So before we get started with the math activities, take some time to think about your breathing. Right? If you want, you can close your eyes. Take a deep breath in, take a deep breath out, and then watch this video and then just kind of write down how did it make you feel after. Um, take 2 minutes of your day today and try that yourselves. Okay, so those of you who just did that with me, hopefully it was kind of nice for you. I can say here's what I wrote after. I feel much more calm after this exercise, as if some of my daily stress has been lifted by focusing on my breathing. My breaths became more regular than before, and my mind can focus a little bit better now. Actually, this was really nice to me. Hopefully, you enjoyed it as well. Sometimes, it's something you can always do. Is you can always just remember to go back and focus on your breath when you're feeling stressed or anxious about anything. It's a nice thing to do. So today we're going to talk about periodic functions, and you might have never heard that before, that term, but I'm just going to read this slide with you. Like many processes in nature, your breath moves in cycles that repeat over time, right? That inhale, exhale, right? And it repeats over and over again. And any process that does this can be modeled with what are called periodic functions. Periodic means it repeats over a certain period of time. And in this lesson, we're going to look at what some of those look like. So first, I have a question for you. Can you think of anything else that happens in repeating cycles, in sort of a repeating pattern like that, like your breath, and might be modeled with a periodic function? Go ahead, put in a response. Feel free to pause the video. Take a minute. Okay, so I'm actually going to I'm not going to put anything in here because I'm kind of curious more to see what you came up with or what you've said. There are a lot of things in nature and in our lives every day that happen in these cycles and that they repeat over time. So anything, what's great about the topic that we're talking about today is that any of those processes, if we were going to model them mathematically, we would use one of these functions that we're going to talk about today. So here's the unit circle, which you might hopefully remember now, or at least have memorized most of these special coordinates, these special angles. And this is going to be the basis for our sine and cosine functions that we're going to graph today. It's important to remember that on this circle, right, even though we've only listed 16 of the angles, remember that we can redefine these trig functions, sine of x, as the y coordinate on the unit circle, the opposite side of the angle, and the cosine as the x coordinate as the x coordinate of the angle, of the point on the circle. So that's our definition for sine of x and cosine of x, where x is it's a function now of the angle of around the unit circle. So we're going to walk through. So either hopefully keep this, or you can come back to this screen if you need to. But hopefully you've gotten some of this memorized and have maybe a picture in your mind of what it looks like. Because on the next screen, I'm going to ask you to try to fill in this table for the sine of some of those angles. So for example, at 0 degrees, which is also 0 radians, what is the sine of that angle? The sine is going to be the y coordinate, remember. So the y coordinate of that angle is going to be 0. It's going to start off at 0. And as you plug these in, you'll start to see a picture of what the sine function looks like. So go ahead, fill in this table, and come back and hit submit when you're done, and it'll check you, and you'll see what the whole function looks like. Okay, so I'll give you a few of the angles. So the next one is pi over 4. That's the 45-degree angle. And if you remember this, what's the coordinates there? The coordinates are x and y both have the same value, which is the square root of 2, or t, square root of 2 divided by 2, which as a decimal is around 0.7. What's the next angle on here? Pi over 2 is the 90-degree angle. So what's the y coordinate of the 90-degree angle on the unit circle? It's 1. And if you keep going around, you'll start to see an image of the sine function. I guess I'll do one more. The next one is also the square root. Just go up here, actually. Copy that, because it repeats, right? Some of these values repeat. And then at pi, we're at 0 again for the y coordinate. We're back down at the x-axis. And I'm not going to fill in the rest of these. You can fill them in. But if you hit submit, you'll see this is what the sine function looks like with these points kind of going through it. Remember, we only listed some of the angles, but if we filled it in for every single angle as a function of the angle, we would get this entire curve. So now on the next screen, I want you to look at the graph of sine. This is called the sine function. Take a look at its graph and just make note of some important features on this graph. So for example, what is the maximum value of the graph? What's the highest point it reaches? What is the minimum value? What's the lowest point it reaches? Where does it start on the x-axis? In this case, it starts at 0. What happens after 2 pi on the x-axis? So we can only see a little bit here, but what do you think happens after 2 pi? Like after the edge of this screen here, of this graph. And lastly, what is the shape? What shape does it look like to you? How would you describe its shape? Again, try to answer those questions on your own. Take 30 seconds or so, and see what you can write. Okay, so sorry. All right. After you've unpaused it, I'm going to come back here and I'm going to say what I wrote. So it has a maximum value, if you notice, of 1 is the highest value it goes. And if you think about the unit circle, what's the highest the y coordinate goes? It goes up to 1. It has a minimum value of -1. The graph starts at 0 because the y, if we start at 0, the y coordinate is 0. And after 2 pi, it repeats the same values as between 0 and 2 pi. It just repeats this same cycle over and over again every 2 pi. Why is that? Because as we go around the circle, right, after 2 pi radians, we've gone completely around the circle, and then we just repeat it again. We keep going around and repeating that process. So the values, the y values, are going to just keep repeating. And then here's what I said. What shape does it look like? I mean, hopefully if you've answered it, you've seen some of your classmates' responses. I think it looks like a wave, kind of going up and down, or maybe a slinky. But yeah, this is actually, a lot of people call the graph of the sine function, they call it a sine wave, because that's what it represents. That's what it looks like. Now similarly, we can do the same thing for cosine. So go ahead and see if you can plug in the cosine values for the different angles. Remember, cosine is the x-coordinate. I'll just give you one here. What is the cosine of 0 of the first angle? The cosine is 1. It starts off at. And then you can plug in the rest. Go ahead and try that yourselves. Okay, so I'm not going to give all these to you, but hopefully if you've plugged in these points, you'll start to see what it looks like. And then if you hit submit, you can check your points, and all of them should be on this curve, which is the graph of the cosine function. It looks very similar, right? Should look very familiar. And then notice some other, take a look and try to answer these questions again about the cosine function now, instead of the sine function. What is its maximum value? What's its minimum value? Should have set this up for you, sorry. Oh, I can't even number these apparently correctly. Mistakes were made. But yeah, go ahead and see if you can answer these questions. Same kind of questions as before. I just want to get your kind of mind thinking about this. So see what you can notice about that function. What you wonder maybe wonder about it. Okay, so let's go back here and take a look at this cosine function. So I answered some of these questions, and you can check, how did you answer them? But hopefully you noticed it also has a maximum of 1. If you think of the x-axis, the x-coordinate as you go around this unit circle, the highest value is 1, and the lowest value is -1. So very similar to the sine function. Where does it start on the x-axis? Well, here's a key difference. It starts at 1 this time instead of at 0. If you go back and look at the sine function started at 0 when it started this pattern, and the cosine function starts at 1. So that's a key difference. But what happens after 2 pi? It also repeats. After, here's 2 pi now. It repeats this cycle after 2 pi because, again, it goes around the circle and it comes back to where it starts, and then it just keeps going around and around and repeating that. What shape does this look like? Well, I guess, the cycle itself looks different. And we call this a cycle, by the way, a repeating cycle. What is the part that repeats? The cycle itself is different, but overall the function looks the same. It's like a wave, just like the sine function. Do my wave here. Yeah. There you go. Okay. Just for you guys. Just to make this a little bit lighter. Okay. So here's an animation of the sine function. Can you describe what this animation is showing? Try to be as specific as possible. I'm kind of curious. Use your verbal, your reasoning skills here, and see if you can just describe mathematically what's happening in this animation. It's good to come up with your own words for these sort of things. So go ahead and try that. Do that on your own, and then I'll come back. Okay, so hopefully you've written something here. Again, I'm not going to kind of write my own answer because I'm curious what you have to say, and I also think that the important part of this is for you to put it in your own words, because when you do that, it also kind of helps consolidate the knowledge, organize it for yourself of what is happening here. So now we're going to take a look at some key points on the graph. In blue here, you'll see is the graph of the sine function, with 5 of the points highlighted. So we've got the starting point, the first maximum, the first 0, you could call it. Zeros are when it hits the x-axis, or the middle of this graph. The first minimum, and then back to the starting point. And meanwhile, in the red, we've got the cosine function with 1 cycle of the cosine function. Sorry. With the same 5 key points. Why do I call these key points? Because there are other points on the graph, right? It's continuous. But these are important points to recognize because they'll be useful for kind of writing the equations for these graphs later. If you can recognize where's the maximum, where's the minimum, how do I fit this together, using these 5 key points as kind of your skeleton for the graph is useful. And then last, over here, before I take a pause, let's compare the graphs of sine and cosine. So here I've got, to the left are 2 graphs, there's a purple and a orange. Which one is the sine wave, or the sine function, and which one is the cosine function? How do you know? How are the 2 graphs similar, and how are they different? When you see them side by side, hopefully you can see, kind of spot some similarities and some differences much more clearly. So go ahead and try to answer those questions. Take a couple of minutes. I'm going to pause the video. Go ahead and write your own thoughts. Okay, so hopefully you've written some of your own thoughts for this screen. So one thing I definitely want you to notice is that I definitely want you to see is that the purple graph is the cosine function, and the orange graph, orange. By the way, this reminds me, we've been having Thursday night math department game nights hosted on Zoom by different people. Last week's we played Pictionary online using a website called Scribble, and the word came up. You had to spell the word right to get the answer right. No one could spell the word rhinoceros, and it was hilarious. Okay, that's my side. Go ahead and try to spell the word rhinoceros and then check yourself. Okay, so the purple graph is the cosine function. The orange graph is the sine function. How do I know that? Because remember, the cosine importantly starts at 1, and the sine function starts at 0. It's when it begins its cycle. Starts at 1, sine starts at 0. Now, you could answer these other two questions. How are these two graphs similar? How are they different? Hopefully you can see that they are very similar. In fact, they're identical. These two functions are literally like, you could think of them as twins. They're like the yin and the yang of each other. They are literally identical functions. They just differ by a factor of, I don't know, a factor. They differ by a shift of pi over 2. Because if you could shift this graph, this purple one, over to the right by pi over 2, then they would be right on top of each other. But everything else is the same. So I'm going to write this. They are identical, except for and this is a shift in the horizontal direction, the left and right direction, except for a horizontal shift of pi over 2. Let me make that into a math. So hopefully you revert something of your own kind of thoughts here. And then on the next screen, I kind of messed this up. I wanted to have a drawing tool here so I could draw on this, but I kind of forgot to do that. But there's some important vocabulary that we're going to use when we talk about about these two graphs, the sine and cosine function. So I wanted to lay out some of this vocabulary for you, because you'll hear it again next year in pre-calc, and you'll hear it. We're going to use it some more here. It's just nice to, when we're exploring new functions like this, to kind of have a groundwork of the same vocabulary that we're going to be using. So the first key word here is amplitude. Both of these graphs have an amplitude, which is the height that the graph changes from its midline. So if you think of this x-axis right now being the midline, the middle of both graphs of this wave, the amplitude is the height it goes above that and below that. And it's always going to go the same amount above as it does below. So the amplitude here is 1 for both graphs. Oh, I'm kind of answering this question down here already. So that's the amplitude. I wish I could draw it on here. Maybe I'll pull up a picture. Hold on a sec. Maybe here's a better picture of a wave. And it could be sine or cosine, either or. But here's the amplitude, right? It's the distance the wave travels above the middle, this midline, and then below it as well. And the amplitude typically is kind of like a measure of intensity. Sound, which travels as a wave, along with other things, the louder something gets, if I'm talking very loudly, right? Sorry about that. If you have headphones in, the louder the sound, the higher the amplitude. And then there's another thing called the wavelength, or I think in here I called it the period. Same thing, wavelength, period. It's the distance in the horizontal, the x direction, the distance between of one cycle. How long is the cycle? That's called the period or the wavelength. And that will in terms of sound, changing the wavelength changes the frequency or the pitch of the sound. So if I'm talking very high like this, then it's a shorter wavelength than if I'm talking very low. It's a longer wavelength. So that's amplitude and period. then I've got two other things here: a horizontal or phase shift. You'll see it written as a. You'll see it using written with this word. Phase shift means if I shift these graphs left or right horizontally, that's called a phase shift. And a vertical shift, I don't have any of these shifted this way, but if we shifted it up and down, that would be a vertical shift, just like in any graph. Which of these four attributes is the same, and which one is different for these two graphs, for sine and cosine? Think about that, but it should be fairly obvious that the amplitude, period, and vertical shift, I mean, there is no vertical shift right now, are the same. The phase shift, I'm going to call it the phase shift, horizontally is different, right? Because the sine function is phase shifted. You could think of it as pi over 2. Is phase shifted by pi over 2. So that's some vocabulary that we're going to use again and again. All right, next screen. Okay, actually, I'm going to pause the video here because it's probably gone a little bit long. We're about halfway through, so I'm going to pause it here, and then I'll do the next part in part 2.